Now let's talk about the methods of preparation of ethers and other factors. Okay, so this is the synopsis for ethers and phenols. See, first, method of preparation of ethers. This we already discussed in alkyl halides. Just I'll give you a briefing on that. Okay.
Yeah.
So first, if you have an alcohol, correct, that too like an ethyl alcohol, you treat that with concentrated H2SO4, but maintain that around 140 degrees Celsius,
Hmm.
which is around 413 kelvins. In that case, you will major product what you will get is ethers. But if I do the same reaction with concentrated H2SO4, correct, but maintain that as around 170 degrees or above this temperature, then chances are you will end up getting elimination, that too via E2 elimination kind, and you will get alkene. Got it?
Hmm.
So 2 degree and 3 degree are not suitable for making ethers using concentrated H2SO4. You will not be able to use this. Instead, अगर मेरे पास 2 degree alcohol होता, 2 moles of this, and then you are using concentrated H2SO4 and heat, then most likely alkene will be forming as a major product. You will not see much of ethers forming. Then,
Hmm.
so this will be your first preparation. Second is Williamson ether synthesis. Williamson ether synthesis, which we have already learned, that is RO minus Na plus with alkyl halide R dash X, that as it attacks here, X minus will leave, will get RO R dash. This should be SN2 ready. Sorry, this should be SN2 ready because the reaction is
Hmm.
SN2 mechanism based with NaX. Done.
Yeah.
So we did notice that in which cases you will get what. है ना? So if you have 1 degree, you will get SN2, that means ethers. 2 degree, 3 degree, you will get uh, E2 mechanism, alkenes. Okay. So if
Hmm.
R dash X, if at all R dash X are, you know, this one or phenyl chloride, or if you have like this, which is bridged position, then no reaction will take place. No reaction of formation of ethers. Correct? So that's the one thing you
Yeah.
need to understand. Clear? And other than that, we also discuss which case products will not be forming at all. Okay, so I'm not discussing on that part, so we'll leave it there. Okay.
Yeah.
Next, chemical reaction wise, if you notice, chemical reactions wise, when it comes to ethers, mainly it is about hydrolysis. Okay, so this is called cleavage of, you know, uh, ROR group, correct? And this can
Yeah.
be done, cleavage of this can be done by only two reactions. One is via acidic hydrolysis, or one is via HI. So only these two will make that reactions better, correct?
Yeah.
आपको सिर्फ यही learn करना है, ये दोनों reactions, got it? So
Yes.
let's see one by one in which case what will happen. Okay, so let me put this as case one. Okay, what will happen in case one and what will happen in case two. Got it? So case one is if at all I have any tertiary alkyl halide here like this with R, and then I am doing hydrolysis, correct?
Hmm.
Irrespective of whatever the R group is here, whatever be the R group is, you will notice that first protonation will take place and it will convert into a carbocation. plus alcohol here. Done. And this carbocation is going to further attack with water and then convert back into alcohol. Done. So what is the
Yeah.
type of mechanism favorable? SN1. Okay.
Yeah.
So case 2. Even if you have 2 degree, correct? Sorry, let me copy this part. It will be more easier. Okay. Even if you have a
Hmm.
2 degree here, instead of this tert butyl, imagine I have 2 degree here, like this, like this, like this, like this, like this. Okay. The
Hmm.
reaction type is the same. So it is still going to be SN1. Got it? And case 3 is when, you know, this R group, both sides, if you have an alkyl halide group like this, correct? So if both
Yeah.
sides we have alkyl halide with 1 degree, here also it is 1 degree and 1 degree. In that case, first protonation will take place like this, and water will attack on the least substituted side. So you'll get an alcohol here and CH3OH2 plus here. Okay. And which will lose out H plus and convert that into CH3OH. Now, by chance, if this is the oxygen we are talking about, that oxygen will always be carried away with this one. Okay. So this is the tertiary. I mean, this is the primary group. Okay. So remember,
Hmm.
अगर primary होगा तो ऐसे होगा बेटा. Clear? Hmm.
Yeah.
Now let's talk about case 4 here. That is about uh, hemiacetals and acetals. Hemiacetals and acetals. So by chance, if you have CH3, CH, we have OH and OR. In that case, when you do hydrolysis, first thing you will remove out this OH. You will get this as CH3. Sorry. Sorry. You will make this ROH to be removed and convert that into CH double bond O plus ROH. This we have studied as a part of aldehydes and ketones also, correct? This is how it will break up. So what you need to do in such cases is, my suggestion is, just wherever there is OR group, you break such a way that you will give OH above and H below. Done. This is the way to break. Second case, if you have an acetal group CH and we have OR and OR, okay, then you do the same thing. You break here also and you break here also. You will get OH here and H here. Same way you will get OH here and H here. And that on hydrolysis again will give us CH3CH having two OH group. Two OH group is going to convert that into aldehydes. So CH3 CHO plus 2 moles of alcohol. Done.
Hmm.
So I guess the next case is also clear, how to deal with hemiacetals and acetals. Hmm?
Yeah.
Case 5 is when you have to deal with vinylic groups like this. If you have a vinylic group this way, okay. So whenever we have a vinylic group and hydrolysis being happened, basically what happens here is the lone pair is always in resonance like this. The lone pair is always in resonance here, this side, okay, because it is under resonance with that double bond character. Now this time you will break here only. So this is a shortcut, you can remember it. Like in this case, what you do, first protonation will be occurring on this position. So lone pair will be pushed here, pi bond will take here like this. So we will get a double bond with H here, with oxygen here, with CH3 with plus charge. And this on hydrolysis, remember that you will be breaking on this side only. this side only. This side, as you break here on this particular oxygen side, so you will put H here and you will put 2 moles of OH here. So by which the left hand side will convert into CH3 CHO and right hand side will convert into CH3OH. Done.
Hmm.
So wherever the vinylic part is, only on that direction you will cut that, and accordingly you will place that molecule. Okay. Next. Case 6, when you have a phenyl group on one side, so PHOCH3, correct?
Yeah.
Whatever be the case here is, you will always break on this side only, because phenyl and oxygen bond cannot be broken. It will have high partial double bond character, so you'll get H here and O here. So we'll always get phenol plus CH3OH. Got it? So even if you have tertiary group also, so H3O plus, so you'll get PHOH plus with tert oxide. And as you break here, so bond will break from this end and you'll get this as PHOH plus tertiary butanol.
Hmm.
Uh, are these cases clear, beta? These are all the cases of hydrolysis. Hmm?
Yeah.
Right. Same way, we will have the cases for HI also. Okay. So reactions with HI. Reactions with HI. So the first case is, if you have any R, O, R dash, clear, and you are reacting with HI. So first you will make a protonation, just like how we did it earlier with plus charge here. And then I minus can attack on any one side here. Clear?
Hmm.
Now notice if R or R dash, okay? If R or R dash, either of them is 3 degree, then SN1 mechanism is favorable. Okay. If R and R dash, both are 2 degree,
Hmm.
then SN2 is favorable. SN2 mechanism need to be checked. If R and R dash both are 1 degree, then also SN2 mechanism is favorable. And if R or R dash, you know, R and R or R dash is either 1 degree or 2 degree, then also SN2 mechanism is favorable. Either of these two is also SN2 mechanism. Okay.
Hmm.
Let me show you with examples now. Correct. For example, if you have it like this with protonation done. Okay. Now what happens is I minus will directly attack here, bond will break here. Done. So what is the mechanism? SN2 kind. Clear?
Yeah.
Suppose if you have like this, okay, with a positive charge here, then I minus will attack on this position, bond will break on this position, again SN2 done. Clear?
Yeah.
But if you have a third butoxide like this, CH3 with H plus here, then when you try to react with I minus, more than that, first a carbocation will form. Okay. So this will first form a carbocation, then CH3OH, and thereafter the I minus will attack here, and then you will get it as iodine. Done. Tertiary case is also clear, beta.
Yes, sir.
Right. In case if you have a benzyl group like this, okay, with I minus. In benzyl position also, first protonation will take place here. Then the bond will break here first. So you'll get this as PH, CH2 plus and methanol. And thereafter only I minus can attack and we will get this as PH, CH2I. plus CH3OH. Done. This is how it will take place. Okay.
Yeah. Yes.
Yeah. Now, if at all it is being given excess, suppose I gave you a reaction like this way with HI in excess. Got it? So what you will do, you will convert everything. First, you will get the normal reaction and then make sure everything converts into iodide. Got it? Everything
Yeah.
should convert into iodide form. Then,
Yes.
now this is with HI. Whenever you have HI reaction, just need to check out this one. I think that should be more than enough. Clear, beta? As
Yeah.
a reaction will always happen with concentrated HI only. So don't worry about it. So you will be always given concentrated HI only. Got it?
Yeah.
And next, uh, anything else? Yeah, epoxides. As much as ethers are concerned, epoxides are another reactions that you need to check. Epoxides, if you have this way, they will have reaction with OH minus. Earlier, there is no reaction with basic medium, correct? But here, reaction will happen and it will happen in an anti-addition.
Mm.
Got it? And if you react with acidic medium, so first protonation will take place like this, and then water will attack.
Mm.
So here also you'll get this as OH and OH, and this is also an anti-addition. So which means that if you take acidic medium or a basic medium, you'll get still an anti-addition in both the cases. Okay. Here is the important point you need to remember is that when you have an unsymmetrical form in acidic medium, then first you will make an H plus here like this. Then this time the nucleophile which is attacking will always attack on the more substituted side and that will break here. So usually it will always go for the more substituted side. And if you have basic medium OH minus, OH minus does not care, it will follow simple SN2 mechanism and it will always attack on the least substituted side like this. Got it? And if you have tertiary like this and with acidic medium, you'll always get this as H plus. That will give you almost like a complete carbocation here. So like this, and here is the nucleophile getting attached.
Mm.
But all in all, you will notice that they all are going to give us, substitution reactions. Correct? Understood? Via SN2 mechanism. हो सकता है SN2 could be at a bulkier place or a lesser substituted place, but always it is going to be SN2 kind. Done?
Mm.
Epoxides are clear, beta.
Yeah.
Right. This is the part that you need to notice from ethers. That's it. Okay. Ethers have, ethers can be in the form of benzene group also. That is called as anisole. Okay.
Mm.
And that is this one, OCH3. This is the anisole. Okay. Preparation wise, best thing is you take phenoxide, react that with CH3I, and it will become PHOCH3 plus I minus. This is Williamson ether synthesis. Clear?
Mm.
That's how you can get anisole. Anisole, OCH3 will always donate lone pair, so it is a strong electron donating group. Okay. So if you notice its reaction wise, OCH3 If you notice the reactions here, with halogen, it will give you orthopara. So we will get this as OCH3. With X, this is major,
mm,
and at ortho position, it is minor.
yeah,
While if you react that with, concentrated HNO3, if it is concentrated, it will give you at all three positions. Just like phenol, it will give you NO2 at all three positions. If it is dilute, it will give you at para position, which is major.
mm,
In case if you treat this with, disonium salt directly, disonium salt, no reaction. But if it is disonium salt with NO2 and NO2 present here, then it will give you azo coupling.
mm,
Azo coupling is observed. Azo coupling means from the para position, it will attack, okay,
mm,
onto that nitrogen and nitrogen, which is connected with NO2 and NO2. Done?
mm,
This is the azo compound form. Not just that, it can also participate in Friedel-Crafts reaction. So if you have CH3Cl in the presence of AlCl3, you can definitely get OCH3 and CH3
mm,
and OCH3 done at ortho position, and
yeah,
this is major. That's it. This is about anisole reactions that you need to know. Correct? Now, let's talk about phenols. Okay.
mm,
Method of preparation we have already learned. First method is Dow's process. Dow's process is when you take alkyl halide, react that with NaOH in the fused form at a high temperature and high pressure. Correct? And
yeah,
that will turn out to be O minus Na plus, and that on hydrolysis will give you phenol.
mm,
Got it? The same thing can be done with diazonium salt as well. Okay, that is NH2 with HNO2 will give us N2 plus, and that when you react with H2O and water, H2O and heat, you will get this as OH here, right? Third reaction is the same sulfonic benzene sulfonic acid. If you have OH in the presence of NaOH fused, again I'm using fused form and heat. So this will convert into O minus Na plus. Sorry, just H3O plus. If you have simply H3O plus, so phenols will form in this case. Okay, done.
mm,
Right. Next, the most important process in this case, is cumene peroxide process. Cumene peroxide process. So I'll start with benzene onwards. Let us make it as a reaction altogether. If you have an alkyl halide in the presence of AlCl3, you know that it will go rearrangement and you'll get this form. This is called cumene. And cumene, when you react with O2 in the presence of HNO, the oxygen will get inserted and it will give cumene peroxide. So this is that cumene peroxide form. Done. Cumin peroxide will undergo rearrangement here. So basically, phenyl will attach here, bond will shift here. So you will get this as phenolic form plus ketonic form. Got it? So that's how you can get it. Okay. For this to do, you need to have dilute H plus added. Done.
Yeah.
I guess this part is clear. Right. Next, these are the preparation reactions. Now let's see chemical reactions. Phenol, pK value of phenol is around 10. And that will be pretty much useful in making it as an acid. So the first reaction is about acidic nature, how it behaves like an acid in various cases. So if I take phenol, you treat this with, you know, NaOH, it can make an acid base reaction. If you react that with OH minus, sorry, if you react that with RO minus, or if you react that with NH2 minus, if you react that with CH3, C triple bond C minus, if you react this with RCO minus, H minus, okay, phenolic group H minus, or you can react that with HCO3 minus, HCO3 minus. If you react with X minus, correct? In case if you react with X minus. Next, if you react with only aluminium, what would happen? Okay, and if you react with only sodium, what would happen? Sodium. Okay. Now notice in all these cases, first you will get phenoxide ion here and H2 gas. Okay, sorry, H2O, acid base reaction. Here I'll get phenoxide Na plus and ROH, and here I'll also get phenoxide ion plus NH3. Here I'll get phenoxide ion. Sorry, here it should have been CH here, CH. So that will convert into CH3, C triple bond. Sorry, C minus only. C minus here. So triple bond CH. So this is forming. Now here you are expecting this to form this and COOH, but COH is a stronger acid, so this reaction will not take place. Get this as PHO minus plus H2. So this reaction will take place. Next, PHO minus. We are expecting this reaction to happen, but H2CO3 is a stronger acid than phenol, so this reaction does not take place. So phenol does not give a positive bicarbonate test. This we have discussed before also. So try to recall that. With X minus no reaction. With aluminium, it will become phenoxide PHO minus thrice Al plus H2 gas. With sodium also, it will become phenoxide PONH plus and half of H2 gas. Done. So these are all the acid-base reaction with phenol involves into. Any doubt?
Yeah.
Clear, right?
Yeah.
Right. Now, usually how typical reactions are being made here, you can notice this one. For example, I'll take one simple example here. Suppose if it is being given something like phenol and reacted that with NaOH and I'll get a compound A. Okay. Compound A is reacting with alkyl iodide to give compound B. Okay. It is also reacting with triple bonded you know, group here like this with uh, Br here. So that will give compound C. All right. And along with that, it is been treated with D2O to give compound, sorry, to give compound D. So you know that A here will be equal to phenoxide ion. B will be here equal to, O and pH. Now this one with minus here OPH will come. This carbon will take OPH. And D, uh, phenoxide can take H plus. So that makes, in this case, it is D plus. So PHOD will come. Okay. Right. Next, phenol mainly involves into name reactions starting with Reamer Tiemann reaction. Okay. Reamer Tiemann reaction is when you take phenol, react that with CHCl3 plus NaOH, and this will give us phenol and CHO. Okay. So this is major product. The other one, which is at para position, this will be minor product. This is called salicylaldehyde. So this is salicylaldehyde. Okay. Now when it comes to CHCl3 here, correct? Now it will form a carbene here. So these terms are important. Okay. Formation of carbene. Formation of carbene. That is CCl2 empty orbital. This is what is formed. Okay. And intermediates, what kind of intermediates you will see here, like this O minus and double bond like this with C. CCCl2 minus. This is one intermediate that will be formed. Next, O minus, sorry, यहाँ पे H and plus है इधर, ये वाला. Then we can have CHCl2 with aromatic ring here. Got it? So this is the one which it can form. Okay. इस तरह से intermediates बनते हैं. The other intermediate will be double bond here, double bond CH, Cl, and double bond and double bond. This is another intermediate which is formed during the reaction. Okay. So learn how the intermediates are forming in this case. Clear? Now, if benzene, I mean phenol, is been treated with CHCl3, correct? But this time with KOH. If this is KOH, then the attack would be at the para position. So this is major. So in this case, this is going to be major product. Done. Next, we come across an abnormal Reamer-Tiemann reaction wherein you can take pyrrole instead. You can take pyrrole instead like this. Pyrrole is aromatic as well. So then when you treat with CHCl3 and KOH or NaOH, in that case, what we get here is this will turn into a pyridine ring like this at a beta position, getting a chlorine. So this is the major product. Clear? Another emerging abnormal reaction is like this. If you have a double bond and double bond here, okay, and you are treating first that with ETO minus Na plus, and that is followed by CH, let's say FCl and Br. So basically, first it will form an aromatic ring. This is the aromatic ring, and then the attack of ClF3 here, ETO minus is taken. So it will again remove bromine and hydrogen. Those two are good leaving groups, HBr. So, and this will get a six-membered ring, but this time you will not have any nitrogen like this. This is the way it will be. And fluorine is the one thing that is left over here. That's it. This is the product form. Clear beta?
Yes.
This is a Riemann-Tiemann reaction. Next one is Kolb's, reaction. What is the Kolb's reaction? Same salicylic acid, same salicylaldehyde formation, but this time using, you know, carbon dioxide. So not aldehyde, but acid. So CO2 in the presence of NaOH, and second thing is hydrolysis.
Yeah.
OH, and here we will get COOH. Got it? So this is
Yeah.
major. The other reaction which can get here, but that is like a Riemann-Tiemann reaction, is CCl4 instead. The first step itself is CCl4.
Yeah.
Then CCl4 also followed by NaOH. This is Kolb's reaction. And other reactions, if you notice, where we have phenol, phenol reacting with zinc. So that will become benzene plus ZnO. So reduction is taking place. Okay. Next, phenol, typically when you treat with K2Cr2O7, oxidation will take place. So this is what we call it as benzoquinone. You get the formation of benzoquinone here. Okay.
Yeah.
Clear beta?
Okay. Yes.
One second. Next one, phenol has this kind of reaction. Basically, it's not phenol, but a compound like this, C double bond O CH3. If this is being heated, you will get a phenol form here, and we'll get C double bond O CH3 plus OH with C double bond O CH3. Now this one will be major, this one is minor. We call this as the, you know, Fry's rearrangement.
Mm. Uh,
This is Fry's rearrangement. Next, if I take 2 moles of phenol, right, 2 moles of phenol, react with this keto group in the presence of H plus. So in the presence of H plus, the lone pair from oxygen will take, lone pair from this oxygen will take and attack H plus, and thereafter from the para position, this will attack here. Okay. So from here, so we can, sorry, so we put it like this. From this side, we can have two compounds, and here also you can have two compounds. This is what is called. Okay. So this is called bisphenol. All right. So OH and OH will be here. Sorry. Same case we can do it with phenolphthalein. So if I take 2 moles of uh, this compound and treating with anhydride here, this is called phthalic anhydride in acidic medium. So you will get phenolphthalein formation. Double bond O here. And now at this one position, we can have phenolic groups connected, which done. So what is this one? Phenolphthalein. So what is phenolphthalein case? Okay.
Yeah. Yes.
Right, but I think these are the main reactions that you need to learn it from phenols. Clear?
Yeah. Have you sent the ether and phenols PDF and